Hello, assalamu alaikum friends. Today we are discussing about rudder control, and you can see this rudder, and rudder is controlled through the FAC, and also there are some other computers are involved. We will discuss here. So in normal, to control the rudder, we use FAC, ELAC, FMGC, and for rudder trim actuator in manual mode we use this rudder trim control panel for manual trimming. Also we have a function of rudder travel limitation unit and yaw damper actuators. Basically yaw damper actuators move this rudder here. Two yaw damper actuators are available, one with FAC 1, other one is from FAC 2. At a time one is in working condition, other second one is in standby mode. So we will discuss about the rudder control, and here you can see that rudder is controlled by computers, either by the ELAC or by the FAC. When the autopilot is not engaged, first case we discuss here, when the autopilot is not engaged, so when the autopilot will engage, this line will come down like here. But in this condition autopilot is not engaged, so it is like this, and ELACs are available, so it is like this. When the ELAC will not be available, it will come down. So in normal condition, when the autopilot is not engaged, rudder is controlled by the ELAC through the FAC like this, and rudder command is given by the side sticks to the ELAC. For example, in roll command, with the side stick, roll command goes to the ELAC, and with the ELAC it goes to the rudder. Also in some other conditions where it is necessary to use the rudder, all commands are commanded, and commands are made inside the ELAC. So in normal law, without autopilot, ELAC controls the rudder, and yaw orders, like here, yaw orders goes to the rudder by ELAC. And which functions are available in rudder? The functions are available here, you can see these first one, dash roll damping, engine failure compensation, turn coordination, rudder travel limiting law. All the functions are available when the autopilot is not engaged by the ELAC. These functions, dash roll damping, engine failure compensation, turn coordinations, rudder travel limiting law, available by the ELAC. Autopilot is not engaged, no problem. With the side stick or with the aircraft maneuvering, we can use these functions directly with the ELAC, like from here to here and then here to here. all the functions are available. So also when the autopilot is not engaged, one more thing we have, you can see here, autopilot is not engaged, so manual rudder trim control available from here. Manually you can use this rudder trim actuator. And now we will discuss about the functions in normal law available with the ELAC. All the functions you can see here with the FAC inside. Here it is written, this threshold damping for the aircraft moving in Dutch roll. When its yaw movement disturbs, Dutch roll damping control the rudder movement. Also, in case of engine failure compensation, here when the engine fails in case of takeoff, you can see here, takeoff, go around, runway mode, after landing, runway mode, takeoff condition. If the single engine failure, it controls the yaw. When the autopilot is not engaged, it controls by the ELAC. Also in go around mode, when the aircraft is going around, so same, in case of single engine failure, it controls the rudder. Also in the runway mode also these three functions available with here to your damper actuator through the ELAC. And also about the turn coordination. In this picture you are seeing about the when the autopilot is engaged. So when the autopilot is engaged, roll commands are from the FMGC, but we are discussing without autopilot, so the roll commands will come with the side stick to the ELAC, and ELAC then give the turn coordination command to FAC, and then FAC to onward it will go to the yaw damper actuators. Also rudder travel limiting law. When the speed is increased, the rudder limit decrease. So ELAC also controls from here, then here to here, rudder travel limiting unit. This unit is installed somewhere here. Also you can use the manual control of trimming the rudder trim actuator. It's also installed somewhere here. So without autopilot, all the controls of Dutch roll damping, engine failure compensation, turn coordination, and rudder travel limiting are controlled with the ELAC. So now we will discuss when the autopilot is engaged. So when the autopilot is engaged, this will come down like this, and it will bypass these signals from the ELAC, but ELAC must be serviceable. Without ELAC, when both at least one ELAC should be serviceable for the autopilot engagement. When both the ELACs are filled, like here it is shown, when the both ELACs are unserviceable, autopilot cannot be engaged. So when the autopilot is engaged, all the functions, touch damping, engine failure compensation, turn coordination, radar travel limiting law, and you can see here radar trim actuation is controlled with here with the autopilot. One difference you can see here, that the data which was previously given by the side stick when the autopilot was not engaged, roll command was given by the side stick to the ELAC. Now it is not giving to the side stick, is not operating, so roll commands are given to by the FMGC to FAC, and then FAC to yaw damper actuators. Also when the auto land available, so when the auto land is available, then also FMGC give the yaw command in auto land mode, like this. It controls the yaw damper actuators in CAT 3C. And here you can also see this one, autopilot is engaged, it is like this. So radar trim actuation, when the small movement is necessary or large movement is not necessary, when the yaw dampers are not necessary to use, with the help of trimming actuator we use this to move light movement of radar. And one more thing remaining, I think. Yes, when both the ELACs are unserviceable, not single ELAC, both ELACs are unserviceable. 1 plus 2, 1 plus 2, serviceable, unserviceable, this will come down like this. Both ELACs are unserviceable, this is here, and only touch roll damping alternate law is available. In this law you will not have engine failure compensation, turn coordination, and turn coordination will not be available, engine failure compensation will not be available, and yaw damper actuator will limit this law also, radar travel limiting law. This will be affected also, not completely 100%, but almost it will be totally based on the FAC, alternate law. So here simply the movement of the radar will remain from 30% to 30 degree in case of A320 aircraft, 30 degree movement of radar in normal case, it will come to down about 5 degree. In 319 case, 319 case, in which it will come down from 30 degree to 5 degree, and in 320 case it will come down from 25 degree to come down from 5 degree. Also these functions will not be available, engine failure compensation, turn coordination no more available, and also no autopilot will be available. This is very important. And this will come down like this. So when both legs are filled, autopilot cannot be engaged anymore. Engine failure compensation loss, turn coordination loss, rudder travel limiting decreased, and alternate law, very limited options are available. No auto land, nothing. And manual trim is available. You can see here in alternate law as well. So one more thing, ADIRS data. In ADIRS data available to also the FAC. When the FAC is in control or autopiloting is engaged. Also this ADIRS data is available to ELAC. So when the ELAC controls, ADIRS data used by the ELAC, or the FAC controls, ADIRS data used by the FAC. So this is all about that. Thank you very much. Allah Hafiz.